Okay, good afternoon. My name is Marco Russo. I work at Secret BI. We produce content about DAX data modeling for Power BI and analysis services. Now I should say also Fabric, but actually it's just a rename, so that's okay. I mean, for the part of the semantic model. This session is about window functions in DAX. And the goal is to understand how the window functions work more than just looking at the functions by themselves, because of course I will show you a few functions, what they can do, but the goal is to introduce a concept, which is the concept of the apply semantics. The window functions are relatively new in DAX. They have been introduced more or less 1 year ago, and these functions are the foundation for the visual calculations in Power BI. With a big difference, visual calculations are limited to the visual. Window functions can be used in any measure in the model, so they are actually more powerful, and they could simplify the code that otherwise would be longer in many cases. In a few cases, window functions can provide a performance advantage over the counterpart in DAX. Most of the times, no. So if you assume that, oh, window functions are faster, as usual, the first answer is always, it depends. In a few cases, they could be faster. In other cases, they are not really faster. So I will not talk much about the performances, but just wanted to give you an idea. So these are the table functions that we will see. Index offset window are table functions. The goal is to return tables. Then we have scalar functions, functions that return just a value, in this particular case, a number. A common element of the window functions is that they work on tables, and these tables can have a sort order and can be partitioned. So they could have internal grouping that are using for certain logics. I go straight to the first function, which is index, and at a certain point, I will slow down because I have to introduce a concept. I go back one slide. I will introduce a concept that you can see here, apply semantics. I already mentioned this term. You know, DAX has the filter context, the row context, the context transition. Window functions introduced the apply semantics. The new visual calculations introduced the visual context. So as you can see, instead of simplifying things, we are going to increase it, if you want to understand how it works. Otherwise, you get the blue pill, and everything is wonderful. No problem. No problem. Okay? Now, but if you're here, you have the red pill. I hope always that I mention the right colors, but the reference is Matrix for those of you that didn't see the movie. So let's start with index. Index is a function that allows us to get a table. The table must have a sort order, and we identify a particular row in this table. And the first row has the number 1. So it's like Visual Basic, okay? The first is 1. For those of you like me that come from C, C#, C++, Java, it should be 0. No, it is 1. Now, how does it work? So first of all, I prepared a demo file that you will be able to download together with the slides from the session here on the website. And let me go at the beginning. Let's go to the beginning. Let's remove something that is not really useful, and let's try to increase the size. So the first thing we do, we want to analyze this function index. Let's also open, oops. Sorry, I forgot to open the Zoom it, so this is easier to read. So my goal is to talk about index here. So index is a function that will retrieve the first row from this table that has this sort order, order by. So this is pretty much the concept. A model, a table in the model doesn't have a sort order. So you always have to provide a sort order in order to identify which rows you want. And as you see, the table we are going to identify, this brands and sales, has been created with add columns. Add columns is getting the list of the unique values from the brand table and is computing the sales amount. So just to take a look, so what is the original table? So if I execute this code, So I execute just the code that starts from evaluate. Let's see if I can do that. Evaluate. I want to do the add columns, and I want to show the result of the add columns because I know what is the table that we provide as a parameter to index. You see that this table is product brand, compute sales, which is the measured sales amount, sorted in a descending way by sales. So the first row, and this is actually the number that you see here. This is the number 1, number 2, number 3, and so on. Index gives me that row, number 1, number 2, number 3, okay? Very easy. So the result of index, in this case, let's change the return here. So if I write return result, I can see that the result of this evaluate statement is the single row adventure works sales, which was the first one. What if I write 2? Well, if I write 2, I get the second one, right? So if I write 2, and let me just, this was supposed to be made with DAX Studio, but I said, well, we have a new feature, so we use the new feature, but it's not so easy. Okay. Second one is contoso, and so on. What if we want to get the last one, -1? And with -1, we go to the last one, tailspin toys, which was at the bottom. So negative starts from the bottom and goes up. Okay, that's the idea. Positive, negative. Go back to the slides 1 second. So this is index 1, index 4, -1, -3. So good so far? So far so good? Question? So if I change, the question is, can I change descending to ascending? Of course, yes. You can decide whatever you want, and of course, at that point, what is now negative becomes positive in the opposite. So you can decide the sort order. Okay. Now, what should we have done without index? Well, the first one is easy. You can write just a top n, and top n is good to retrieve the first row. Without index, it would be pretty easy, but the second one would require much more code. And if you look at the code, it's not just that we have to write more code, but actually the execution time takes longer. So this is one case where index is faster than the alternative, because the alternative requires multiple processing. So far, so good? Now, what if we have ties? Because let's go back here. So if I skip these examples that you have seen in the slides, I think they don't add much value. But if I take a look at the next example, so you see that here we have this brands and sales, which computes the sales for each brand, rounding the number to the closest million. So this means that there will be several rows that are identical. You see that now we have rows that are identical. Now, what happens when I use index 2? I provide the order by descending, by sales, and the number 2 will be just one of the rows. Oh, yes, I have to go here, result 2. It's one of the rows that we have, contoso. Now, why contoso and not wide word importers or the fund company? As you see, if I look at the number here, it would be number 3. But we obtain contoso as number 2. Why? What happens? Well, the way the sort order is defined when you have ties is not defined. But from the point of view of the not defined means that we can expect any sort order, okay? From the order by, we can expect any sort order. From index, it's the same. The algorithm is not the same, but the algorithm that is used by index is deterministic, which means that there is an algorithm that will identify a unique row for each position. You don't have to make assumptions about this position specifically, but you know that if you execute this code multiple times, you will always get the same result. something that is not true for the previous execution. This is possible because the algorithm, in presence of a tie, in this case we sorted by sales by just saying I sort by sales and there are two rows with the same value, the algorithm uses the other columns of the table to establish uniqueness of the rows. Which means that what happens if I have the same value across the row? So if I execute this code now, I have the table that only has sales. Now we have multiple rows with the same value, 2 million, 2 million, 2 million, but we don't have other tables, other columns, so how can we establish which one is the second row, which one is the third row? We cannot. If I execute the code that includes the index here, this code, so I'm going to execute this code now, which has index 1 ordered by, and you see that there is an error. You cannot use index if you have duplicated rows. Okay, you can have ties in the columns that participate to the order by selection, but you have to provide unique rows. Otherwise, you can encounter this issue. Questions so far? This is it. This is the easy part. It was just a warm-up. Now, we talked about that, and let's go to partition by. So far, I used index returning one row. But index is a table function that could return multiple rows. And one of the arguments of index can provide the partition. What is a partition? Well, is a way to explain, well, I want to split the table in different groups, in different partitions, based on columns. At that point, index will repeat the process for every group, for every partition. So the result of index could be multiple rows, one for each partition. In this example, we're saying, look, I want to get from the table brands and sales by category, which has two columns, category and brand. We want to partition by category, and for each category, we want to get the first product. Give me the first product for each category based on sales. The result of this index will be a table with multiple rows. You see the table we start with, so let's go to the example in Power BI. So I execute this code where I just show the table that we have as a starting point. So you have category, brand, and sales. And if we look at the sales value, if we get the highest value of sales for each product category, we would like to see also the brand that has the highest value. So the next step is that, okay, within the same define, let me just reduce this a little bit. So I'm including the variable, the first evaluate to see the result of the entire table, and the second evaluate gets from this variable just the first row for each category. Exactly what we have seen in the slide. So if I execute this code and I switch to the second result, here we go. We have for each category one brand. As you can imagine, this approach could be extremely useful to create, I don't know, a filter for a calculate statement. Or if you are in control of the query, you could use this to generate a result. But if you are creating measures in Power BI, you probably cannot use index as the result of the measure. You can use index to include a particular filter, which will include, for example, give me the top 3 products for each category and show me what is the value of the top 3 products of each category compared to the total of all the products, something like that. It becomes a much easier syntax to write. I would say, sorry, a much shorter syntax to write, not easier, sorry. Okay, so here we go. So this is the meaning, the visual meaning. First, brand for each category based on sales. Okay, this is what partition by is doing, connected to index. Now, these concepts, order by, partition, are present in all the window functions. Okay, so once you understand what order by means, what partition by means, you can apply the same concept to all the window functions. But you can skip the table argument. This is a valid DAX syntax. You can say, give me the value. So this calculate is saying what? Give me the value of the first year somewhere in the current group, I would say. What does it mean? So if you look at the result, this is easy. This is a classic example. It just works. Wonderful. Oh, we get the previous year. Give me the sales of the first year for the same brand. You see, right? This is the value of 2017 that is repeated here. This is the value 2017 for another brand is repeated here, and so on. So sales first year in this visualization becomes, give me the value of the first year for the current brand. But if you look at the code, we never wrote brand, right? But we understood that index works with a table. What is the table used by this index? We didn't mention it. What is happening? And so that's where we, sorry, let's go back here. That's where we have to start to investigate on what is happening when we don't see the code. So let me go down here and let's highlight this. Because the argument with the table is missing, what happens is that there is an all selected that uses all the columns that you used in the order by. Okay? So from a DAX standpoint, we say, well, the table we provide is the table that has all the columns included in the order by, but only limiting the visibility, the content of the values of these columns to the values that are visible in the current visualization, all selected. So if you have an external slicer that is only filtering, I don't know, 2 or 3 years, you see only those 2 or 3 years. You could have wrote all selected date here, and you will get the same result. So if I execute this code here, the result is what we have seen in the slide, no differences. Okay, so now we know, okay, index, when index doesn't have an argument that defines the table is implicitly assumed to be the result of all selected. We already mentioned that, this is another example, but it's still the same. So you see that if I use the positive value, I get the first one. If I use the negative value, I use the bottom one, the last one. Remember, we order by year, so 1 means the first year, 2 means the second year, and we are just filtering the year. So because in this cell, think about this. In this cell, the first row, the filter context for the evaluation of the row of the measured sales amount is brand and year, right? Because these are the only 2 model columns that are in the visual. These 2 values are moved to the filter context thanks to the context transition of calculate. This is like your measure, right? Oh, sorry. This is like your measure. Your measure calculates sales amount, is computing sales amount in the filter context that initially has Contoso 2017, but then by or 2018, but then the filter over here is replaced by the result of this index. So this index returns a table. This table has only 1 year. This year replaces the year that we have in the row. So for example, for 2018, 2019, 2020, the result of this order by here is putting always 2017 in the filter context, and so the result is always 2017. For the last year, the same happened for 2020. And we don't have to specify the brand, because the brand is what we had in the visual. Now, oops, sorry. Let's see, okay. So index is the absolute position in the table based on the sort order and the partition that we define. Now, let's enter into another function, which is offset. Offset is a function that moves back and forth from the current row. Okay, well, what is the current row? Aha, that's a problem, right? Because from a visual standpoint, so if you look at the report, it's pretty clear. We want to go back 1 year. If you read the code, it's easy. Calculate sales amount going back 1 year. So when you look at this code, you say, okay, if I'm in the 8 datum 2019, the number I want to see here is 8 datum 2018. It's the same principle. So you are providing a column as an argument to offset. And offset says, oh, order by date year. So I'm assuming the table is all selected date year. Same thing, like index. Now we have the list of 2017, 18, 19, 20. And it has to go back 1. Okay, so I'm in 2019, so I go in 2018. But wait a minute. The measure we're computing, this calculate, is computed in a, it starts from a row context, but it goes to the filter context. And when sales amount is evaluated, when this measure sales amount is evaluated, it is evaluated in a filter context. Calculate removed everything. So how can offset evaluate the notion of current row? What is the current row we're mentioning? Is it the row context? Is it the filter context? Is it something? Well, unfortunately, in order to explain what this current row is or could be, we have to introduce the apply semantics. And the reason is that while in the previous example, I could have said, well, the current row context in add columns is the current row, this is not valid for the example that you see here. If I write the code that you see at this point, I simply removed date year from the visual. And by removing date year from the visual, instead of getting an error, oh, you don't have a current year, we get a result, we get a number, which also has us, is predictable. We can explain what this number is, but the first time that you see this number, you have no idea what this number is, because it's just a different number, but it's not 1 year. What is this number? So now we use this example to introduce the apply semantics, which is used every time a window functions in DAX has to compute something, right? The current row. So the idea is that the apply semantics tries to mix the row context and the filter context together. And we have a few details to learn, so let me start, because we don't have much time, so I want to start from this example. Remember, I want to explain what we have seen in the previous slide. In order to explain that, I start with another smaller, simpler example. And the simpler example I want to show you, before I show you the slide, is something I prepared here. Let's see here. Where is this one? So I start with this example where I have just 3 customers. Okay, I want to show 3 customers. Let's take a look at these 3 customers. In reality, I don't have 3 customers. I have 2 customers. I have Kenneth Wilson and Silke Probst. The first customer, Kenneth Wilson, has 2 rows because she or he, Kenneth is male, right? Sorry, I'm Italian. So don't be okay. For us, it's strange. So there are 2 customer keys because the customer changed address over time. Slowly change dimension type 2. So from the point of view of the customer name, we have 1 customer name. But from the point of view of customer key, there are 2 versions of this customer. Okay? Now, why am I showing you this example? Because in the next example, I show you that given the filter over these 3 customers, which are in reality 3 versions for 2 customers, I want to show the orders made by those customers over time. And for each order, I want to show the sales amount of the order. So we see the order number, the order date, and the sales amount of the orders of these customers. So remember, every order has one customer. We know that because in the model, every order has one customer. But we are not showing that information here at the moment. However, we know that internally, if I consider every order, I know that every order is owned by, has been made by one customer. And if I look at the customer name, not at the customer key, at the customer name, I would like to get the value of the previous order made by the same customer name. Okay, that's my goal. How can I do that? So the next step is that we go, let me go back to the slide 1 second because I might have. So the slide shows the hidden information, right? Each order has a customer. There are 2 different customer keys for the first and the last order, but in reality, they belong to the same customer name. And so when you look at the order that you see at the bottom here, this order should retrieve the value of the previous order by getting the value of the order that has a previous order date or the previous number. Makes sense so far? So one customer is, so this is what we want to do. Now, at this point, I already shown you this example that has just the current order value. This is the code that I shown you in Power BI here. This is exactly the same result. And the next step is, okay, let's add the value of the previous order. How can I do that? Let's take a look at the, so in order to get the previous order, I say, look, I want to get the previous -1 order number, where? Based on customer name. But of course, you have to provide the table, the famous table, right? Because the table will not include, the table would include at this point all selected customer name and order number, but by using summarize, we want to limit the analysis to only these 2 columns because we are not interested, for example, to the order date and other columns that we might have. So if I look at the execution here, let's see if I have this one. Yes, this one. So I have to select this code and I have to execute this code. You see that what happened is that simply it appeared in the previous order column exactly what we have seen in the slide. So the code works, but we have to explain, okay, but it's a kind of magic. How does it work? So the thing is that by using summarize, we created a list of order number and order date, okay? Now, the evaluation context that we had before summarize, the evaluation context was order number, order date, current order. But because current order is the result of a measure, it doesn't count. For the filter context, only the columns that belong to the model are moved into the filter context. So let's say that this is the filter context we had at the beginning, only this area here. Okay, this is the evaluation context, the filter context. In this evaluation context, we executed this summarize. So summarize is executed only once, not for each row, only once, and it produces this result. The result has 5 rows, just different values, the name of the customer and the related order number. So we materialized in a table the missing part we didn't see before. The next step is, okay, again, remember, we have this table created once, and we had to identify what is the row we want, because we had to go to the previous row. So let's say that we are considering the order number 320602. Well, this order number exists also in the source table. Think about this. We have, in the evaluation context, we have a table. In each row of this table, there is a column that has a value, and there is the same column from the same column in the model, also in the source table of the window function. The algorithm tries to match all the columns that are present, both in the evaluation context and in the source table, all the window functions to determine which is the current row. And so at this point, this match is made. And so what happens is that for each row that you have here, the current row in the other table is automatically found this way. And as you see, the sort order doesn't matter. So what matters is not the sort order, but the actual position, because you could have changed the sort order, and you use the sort order in a different way to get the previous value. So because we used the partition by name, the previous value, the previous row for, the previous order number for this row is this one. The previous row for this element here. So if I consider this other element, there is no previous row, it's blank, because we are at the boundary of the group that has only one customer. And okay, so when let's go back to the previous slide. So sorry, to the example I have here. We still have a case where what we want to do is still visible in the result. So you can understand that for this value, we got just one value. So each row has only one value and one row as a result. That was easy. What happens, though, if we have a case where we have the previous year? So you see that I'm getting the previous -1 year, but I don't have the year in the visual. I have in the visual only continent, sales, and then I have sales previous year. Yes, I have a filter only for 2 years here. What does it mean? The value of sales in Europe here is 2018 and 2019. But as you see, sales previous year provided a number, but what is this number? What does it mean, right? This number can be explained, but of course, how offset is working? Well, again, if we look at the summarize here, you see that we are getting the continent and the year, but we are considering all sales, which means that the list that we obtain here doesn't have only 2018 and 2019, it has all the years. But of course, in order to explain that, it's better if we move forward and we take a look at the slides. So the summarize had a filter. Imagine you have a filter in the filter pane of your report, 2 years, 2018, 2019. In the result, we have seen that Europe has, for sales, the sum of those 2 years, and we want to understand what is the result of sales previous year. So for the cell that we are analyzing, the filter context has 2018 and 2019. So there are 2 rows, 2 years selected, not one. So what is the meaning of current row here? Let's move forward. Because we are evaluating a single row, Europe is part of the filter context. So for the cell that we are highlighting, the filter context has 2 filters, 1 value for continent and 2 values for year. At this point, the source table that I created with summarize, that has all the continents, all the years. Now, because of the apply semantics we defined before, how do we match the source table with the current evaluation context? Well, if you look at the result of offset, if we display the result of offset, offset will return 2017 and 2018. Why? Because offset says, for the values we have in here, for each value, I get -1 within the current window, within the current partition, the current group. So what is happening is that even though 2017 was not in the original filter context, because we provided a table with summarize that had all the years, then we can consider the previous year including 2017. And so what happens at this point is that this offset result, the result of offset that has been computed, getting every year and applying offset for every row, is part of the filter context now, replaces, I go back one step, because the offset result has both continent and year, it overrides the existing filter context, removing the filter by continent and year. So the value that we have seen in the result previous year is give me the previous year for any of the years selected in this cell. Is it what you want? I don't know, it depends, but this is how this system works. So when you use offset or index, you never have an error, but you have to be aware that even though when you have a particular value, you have a single row in the visual and you go back one, it's clear what it's doing, it's visible. But in order to explain what happens when that value is not visible, you have to understand that the behavior, the internal behavior, is actually an iterator over all the values, and it applies that offset, in that case, to all the values, and the result is the union of all these rows. So this is something that you have to be aware of, because if you use this function in a measure, it could be used in a situation where you don't have a single year selected. So a simpler example is, I want to go back to the previous brand. You decide to create an arbitrary report where you have a list of brands and sales amount, and you want to go back to the previous brand according to the order that you define. In this case, for example, by sales in an ascending way, so from the lowest to the highest value, you simply go to the previous value. This could be very useful to create, for example, the difference between two contiguous accounts or two other elements. It's clear that you use more often this technique for the time, for computing a difference over time, but this is another thing that you have. Window. So if I go, in this case, I prefer to use an example where we use a measure, right? Window is a way to return a range within a table. So, for example, in this case, the value that we look in the average is obtained by using this function window. Once again, all the window functions work the same way. You have a source table. If you don't provide a source table, it is automatically obtained by using all selected of the columns that you provided. And in this case, we only use the year-month number because we have a chart that has months. We want to get the last 6 months, so we use, in this case, 0 relative minus 5 relative. So window can have an absolute position in the table, like index, or a relative position. When you use the relative position, 0 is the current row. What is the current row? What I described it before, apply semantics with all the complexity. But in this case, year-month number is likely part of the chart because it's the column used to sort the month name, year and month name. So there is a current year month, and we go back 6. And so window is a way to create, for example, a moving average. You probably have seen with the visual calculations similar technique using also functions that have a shorter syntax, but the advantage of window is that you can use window in a measure, not just in a visual calculation. So the underlying behavior of the visual calculations are window functions. You will always see that a visual calculation, usually in a shorter definition, internally evaluates a window functions. But if you create a measure, you don't have the limitations of the visual calculations. Questions so far about this? Yep. Sorry, I go back to one slide because the question is, why didn't I use the partition by here continent? Okay, sorry. The question is, why did I use, in this case, the partition by continent? Because if I didn't use the partition by continent, I guess that the continent will not have been included. I'm thinking, no, in this particular case, I think that it is not required. Because I don't have, the question is, why do I have partition by continent here? If you look at the result here, there is only one row for each continent, and clearly it is not required. Clearly it's not required. The moment I add the country, for example, then we go back. I mean, again, I don't know if it makes sense to compute this calculation. This was more an example to show the problem. I would say that on top of my head, I don't think is required. Sorry, because of the all here. Ooh, yeah. Otherwise, it could get also the partition in the order by. You're right. At that point, it could include if 2017 was included, it would have included also 1 year of the previous continent. Yes. So it's a little bit tricky. If we don't define the partition by continent, the risk in this case it will not change because we have. But if we had also 2017, then we could have probably have seen instead of 2017 the last year of the previous continent summed together. So we want to avoid. We want to split the continent, and so that. Yeah, in this particular case, you will not see the difference, but you will see the difference if you change the filter for the year. Correct. Sorry, very, very technical question. So let me go back because I don't want to finish too late. So we have seen window with the month. We can use window by using the day. In this case, it's the same thing. We go relative back. In this case, actually 61 days, because if you want to do 60 days, you want to. This is not the 6 months average. Sorry, there is a mistake here. This is not the. This is the 61 days average, because if you have minus 60 and 0, you include 61 days. If you want to get only 60 days, you have to do minus 59, 0. Okay. And window could be used, for example, to compute the running total. And the running total, you see that here we have the running total by year, month, and the running total is computed by using this window that says the starting point is the first row, is like index 1, the first row in the order, and relative 0, the current row. Again, the current row according to what we define. Okay, I don't show you the example, but it's pretty clear. The last two functions, I think, yes, are rank and row number. Rank and row number are functions that are used to get the ranking, or I mean, they seem similar, right? Because the row number also consider the sort order. So what is the difference between rank and row number? Well, the difference exists when there are ties. We can see this example here in Power BI Desktop. So if I go in Power BI Desktop in the DAX query view and I scroll down to my rank and row number example here, you see that we have this measure that simulates duplicated values. So rounded sales will show ties. And if I execute this code, you will see that the result has rows that have the same value, like these two rows have exactly the same value. And so rank can be used using two arguments. One argument that defines if it has to be dense or if we have to skip the duplicated values. You see the difference exactly here. So these two values have the same result, 5. They have the same position. There is no way they can be identified in a different way. But the next the next order, the next rank position is 6 if you use dense, 7 if you use skip. Similar to rank X, same behavior, just a different way of using the syntax, and it is using the window functions. When we use the row number, you see that row number has always a unique value. So if there is something that is different in the remaining part of the row, row number is guaranteed to provide a different value, otherwise it provides an error. And so this is the main difference between the two functions, row and sorry, row number and rank. Okay, you will find this function. Okay. I think that the last thing I want to show you is this one. You have seen that in several examples, I provided an explicit sort table instead of relying on all selected. Sometimes because I wanted to use all, but sometimes you want to control that in any case. And let me show you one case. We can see the example in the report. Yes, I have time. Where we can see what happens when we don't consider how the window functions work. Let's take a look at this. You see that I have two versions of rank. I want to create a rank by month, and I want to see the position of the month, consider the ranking by month, where I want to see 1 for the month with the lowest sales amount, 2 for the second one, and so on. Okay, this is the goal. The measure, let me see if this one, good, no, I want to show you the wrong, okay. The wrong measure is this one. The wrong measure has source table computed using all selected date month and sales amount. So why is this not working? Why you see always 2? You see that I always see 2, right? I always see 2. Well, if you want to understand what is going on, you have to make sure that what the source table is doing is what you expect, right? We are expecting every row in the source table to have the right value of sales amount that you see here. So we expect to create in DAX the same content you see here, month value, okay? This is what we expect. But is this what is happening? If we had a debugger, we would open the debugger. If you use Tabular Editor 3, you can do that. But because we don't have a debugger, what we can do, we can try to inspect the value of source table. So we see that there is an error here. So we can try to inspect the value of source table by showing the content of source table. But source table is a table. So how can we transform a table into something we can read? We create a string. I can use concatenate text that iterates the table. And for each row, I write date month equal value of the amount with a comma. This way, I expect to see always 12 rows with the different numbers. Let's try. If I execute the code now, you see that something is strange. So let's go here in the month, okay? January, February, February are empty. March has the same value we see here, and all the other months are empty. That's the reason why the result is 2, because the empty value is like 0, and so the value we have is the second one. But why the values are 0? Well, what is the filter context here? The filter context is year, month name, month number. Because there is a sort by, there is an order by. So we should know that, and for those of you that say, Marco, how can I know that? Well, you can use the performance analyzer, start recording, refresh visual. If you take a look at the query that is generated here, you don't have to read the DAX code. Just take a look at the result. You see that you don't have only the columns that you see. You also have the columns that have been used to sort the data, like the month number. But these columns are part of the filter context, and they have to be included. So in order to fix this code, here, I have to include the month number in the all selected, which is what I did here. So the only difference we have is that we included the month number, because otherwise the table I'm providing to rank doesn't have the data that I expect, and rank fails for this reason. So it's still DAX, even though it's called window function, but it's still DAX. So that's the fix that we have to apply to this code to make it working. And basically the idea is that pre-computing the source table allows you to, 1, control what you're doing, two, to inspect the table, because if you skip the table, you don't see what is going on, you don't see what is happening, and you might see unexpected results. So that is a wrap. Window functions are good functions to navigate through sorted tables. The sort order should be defined in your measures. It works with a strange technique to define the current row, which is called apply semantics. Most of the times this is easy, in easy examples, but if you want to face how you should expect the result, what is the result that you should expect also in any condition, you have to understand how the apply semantics work. It's something that is related to the row context and filter context, unifies the two concepts together, but it takes some time to get used to it. I have to confess, I still have to rehearse the session 30 minutes before to make sure I don't make too many mistakes during the session, so it takes time. So, best practice, pre-compute the source table in a variable, you can inspect it, keep it simple, because it's always the best thing to do. Thank you for attending. Remember, provide the feedback to the for the session. Thank you very much. I'm available for your questions later. Thank you.